Alright, I think we're good. Hello, everybody. Welcome to session 2. Let's go ahead and get into it. We were just doing some clashing. I got some coffee. Um, Decided I'm really enjoying these streams, so I wanted to pump out a couple more, or at least one more. Then I might go do some exercise, and then, yeah, also applied to a couple more jobs, and we'll see what pans out with that. But either way, I think I'll still be able to commit to like an hour or two a week of streaming. I think that'd be okay, regardless of whichever of these jobs I do get. All right, let's see. Oh, and fastest mode. So we're trying to reach 500 clashes. So these are all going to be fastest mode. Um, then again, if we can get like 4 or 5, maybe even 6 or 7 an hour, that'd be awesome. Technically, we should only get 4 an hour if we're using the maximum amount of time. But as you've seen, a lot of them don't require the whole time. So, anyways, without further ado, let's get into it. So, for this one, we have before paying an invoice, accountants need to be sure the related items have been ordered, received, and invoiced. Take the 3 lists of ordered items, received items, and invoiced items and return the list of payable items. The list of payable items. Payable items is a list of items existing in the 3 other lists. List size can be different. List maximum length is 2,000 characters. The items are sorted in the same order as found in the ordered items list. Alright, so payable, actually that's, yeah, payable items equals empty list. Alright, so, we could do this in a couple of ways. First, I'm going to say, we'll just do it if len ordered items greater than len received items, and oops, it's greater than len. So basically, let's see, elif so there's 3 situations. So now I just need to change this to received items is greater than ordered items, and received items. So basically we're just trying to find which list is the largest. Okay, and then do that, else for item in invoiced items, if item in ordered items, and item in received items. Payable items dot append. And I can already see a couple of potential problems with this, but we'll see if it works without too much finessing. Now, we need to replicate this 2 more times with slight tweaks for the first condition. Oh gosh, get out of here! I'm so that's one thing I don't like about CodinGame. Get out of here. I don't want to. It gives too much help, too much suggestions. I need to figure out a way to turn that off. But anyways, so for this one, so the first one is ordered items. Well, invoiced. It's not how I would like to do it. I'd like to have the sorry, real quick. I'd like to have the ordering different, because for the first one we're doing ordered items. So if that's bigger than the other 2 lists, we're going to check every item in that. And then if it is in the other ones, we'll do that. And then we'll do payable. Oh gosh. items. We might have to, let's see, what's the output? So the output is the list. Although we might have to actually do a for loop for printing that. Anyways, let's finish this first. So, first condition, if ordered items is the biggest. Second condition, if received items is the biggest, then we're going to do this for received items. And if it's in ordered items and invoiced items. Oh my gosh. You're struggling today. Okay. So we've got, yeah, this stays the same. You know, either way we're going to append that item to payable items. We have our three conditions. Let's go ahead and run it and see what we got. All right, yeah. So right away, stop. For item in payable items, string plus equals item. Return string plus equals a space. And so that should do that, and then we're going to print. The lag is getting a little better, so I don't know what I did. Oh, geez, get out of here. Print return string chopped at the last one, and we need to create a return string to build. There we go. So we formatted the return string, we build the return string, and we spit it out. Okay, so what? Why? That's just weird. Alright, so we have the correct items. We just have spacing is just ridiculous. Why is that? Hmm. Alright, so I see what's going on here is, you know, I'm just trying to double check and make sure that we actually have the correct answers. So what's going on here is we're putting in a space between each character, and I'm not sure why it's doing that, because like here we have our output is all of this. Let's go back to an easier one. Simple items. We've got D, B, D, and F. So we have that in payable items. Now I wonder. Let's just take a look at this. So we got. Oh. So basically we have. So we're appending spaces to items, basically. There are a couple of empty. Let's see. If item is not equal to just a space, we're going to append it. Let's see if that fixes. Okay, that gets us closer. BD. And I'm guessing this would be BDF. So for whatever reason, found BDF. So if we take this back out, and then format it again to do everything. This should be right. Yes. Now, does that work with everything else? No. Okay, so, um, alright, so the issue I'm having here, oh, geez, we only have like 5 minutes left. So that works for the very first, but see, I don't get why it's appending spaces. Like, if we were to just print out, let's do this again for these so that we can just see. Yeah, look, that's all, those are all individual items. Now, okay, actually, I just realized we're going to have to do if item is not equal to a space in all of these. Well, somehow we're targeting. So for me, it looks like we're taking the biggest, only we're doing every character, not every item. So that's where it's a little counterintuitive here. Where I'm trying to add, like this is like a group of four. I think that's an item. Expecting, yeah, each of these is grouped to a section of four, 4 digits. We're getting them inputted as single digits. So right there, there's one issue. We might not get this one in 3 minutes, but we're getting close anyways. So a couple ways we could go about this is we could join all of this into one string and then split it by spaces. I think that would be the cleanest way to do it, because let's look at this one. Yeah, literally we just have two things, and we have, well, actually we have 3 things here. So that's alarming. So now we're dealing with incorrect information. Like we have 3 values. Let's see, what values is it expecting? I can't see. Make this go down. Ah, whatever. Let's take this back out. So it's expecting these two. 4, 5, 2, 1, 5, 8. Yeah, because there's a couple of things wrong. I'm trying to think of ways that we can mitigate this. I mean, we have. Well, let's see. So this print return string added all of those items. Let's take this out for this one. So we have the 4, 5, 2, 1, 5, 8. 4, 5, 2. Ah. See, this is the one that doesn't belong. Then we have, there's actually a couple that don't belong. So I'm not sure why we're getting that. 4, 5, 7. Looks like this one. 5, 8, 9. So I'm trying to think. Like the issue is we're getting them character by character. We're not getting them in by item. So these ordered items, received items, invoiced items, I don't think those are. Let me try this. Just for giggles. I mean, we've got 1 minute left. Let's see what this does to it. So this should split it. So that's a string, split it into. Ah, it made it much cleaner, and it got us the correct ones. So there we go. And did we get it? Oh, we got it. All right, actually submit that. All right, never mind. We got it. Sorry. Let me actually say what I was trying to say, because I was just racing the clock there. Let's go ahead and look at the code again. basically what was going on is I was thinking that these were already lists, but they were strings. So they were getting input of spaces, which was spacing out the values, but they were also, yeah. So by adding this split method, I forced these to become lists. So that actually made more sense. And that makes more sense why item was individual characters, because for that purpose, these were strings, and so, yeah. Also, that made it problematic because we were checking to see if that item is in any of the other two, which would give us incorrect info. So, yeah. As far as fastest mode, I mean, is it still going? The clash is complete, and we got I believe this is our first. Ooh, I just got something else. What is that? I will make it. Okay, yeah, now it's completed. Now you see the 15 duration, and that's a little beep that, keeps throwing me off. But anyway, so let's go ahead and start another one. I want to look at that and see what that is. Let's do that in a new window. Um, yeah, because that's one. We've been going for about 20 minutes. All right. Anyways, that was just. Wait, is that only one? Jeez. All right. Well, it's going again. Um, what is this? Submit your code 100 times in the IDE, and I need to do it 1,000 more times. Okay, cool. All right. Reverse mode. Okay. For range. I might need to do s plus 1. Print plus. Oh, okay. Okay. And chop the last one. That should be it. All right, cool. That was easy enough. Little 2-minute clash that made up for the other nonsense we were doing. Hey, we're the first one's done. Let's share the code and let's clash again. Just under 2 minutes. All right, that was pretty good. So basically, the whole concept behind that was they gave you a width and height. These were squares, and so they wanted you to print a square consisting of plus signs with width and height equal to s. So that wasn't too bad, making a nested loop. Okay. And will it show? Yeah, I've got 18 points. I just made it to level 8 by completing the 100 clashes, so that achievement put me over. I think that was like 255 experience points. I haven't really gotten any experience, I don't think, from the side clash or the challenges that I've been working on since it. Oh, jeez, what did I do? Right. I gotta share the link. I've been doing a whole lot. There's the link. But I mean, I think I just need to get in the habit of that. Alright, fastest mode. Anyways, convert a decimal number into an English word using hex speak. Hex speak is a variant of English spelling using the hexadecimal digits. There is multiple flavors of hex speak. Ours is defined as follows: hex speak to English A B C D E F Wow. Okay. I'm already not a fan of this. All right. So we've got decimal. We're changing that to hexadecimal, and then we're taking that and chopping off the first two. Okay, I think I could do that. Let's see. So first, let's print hex of n. Let's see if that's getting closer. All right, let's go and leave the code in there. Okay. Okay. And then let's do it print hex n. Oh, let's do return string equals that. Return string equals string of hex of n. And we could even make it crazier, chopped to the 2. And then that's pointless. Return string. And we stop. God, that's so annoying. I try to click on something. It's like, oh hey, by the way, did you know about this? It's like, yeah. Print return string dot upper. I think that's it. Oh, and the 0. The 0's throwing us off. Return. Actually, return string raw. So raw equals that for char in return string raw. If char equals a 0, return string plus equals O. Else return string plus equals char. There we go. So that replaces all of it. And now dot upper. We're just gonna keep stacking them on there. So now let's do return string. Let's see if that. I think I changed everything necessary. Let's go ahead and play all the test cases. Bada bing. Alright, we're 4th, although that guy gave up, so, you know. Alright, submit it. Just under 3.5 minutes. Yeah, just a little over 3.5 minutes, sorry. So go ahead and share that. That is really good. They are really good. And Ruby, huh? See, I've never actually used Ruby. That's a new one. Alright, let's clash again. We're about halfway through this stream. Let's see. I think that makes 3 clashes. Oh, jeez. Copy. Did I get it in time? Alright, fastest mode. Jane is stuck in a tree. Can you help Tarzan figure out how far he will fall before he reaches Jane? Tarzan swings across end vines, which he knows are X sub I meters away from Jane. Whoa, hold on. Sorry, we're gonna have to. The number of vines Tarzan swings on. Okay, so our first input is the number of vines. In descending order. So we're getting closer to Jane with those. Okay, so it's the distance squared. Alright, gotcha. So with this example, we start at 5 away, 3 away, and then 0. So here we've got 2 squared. He falls 4 meters. So the first one will be from 5. Wait a minute. So the first two vines, these are the three vines. So the first two vines, it's got a difference of 2. So he falls 4. Because if we go back to this, it's 2 squared is 4, and then we're adding that to the sum. Now, between this one, it's 3, so it's 9. Okay, so what we're doing, I mean, this could be vine list equals an empty list. I'm going to append, vine list dot append. So we have all of the vine distances, and then why? Oh, append x. You need to know what you're putting in there. All right, so then we do for vine in vine list. Oh, we need a sum. Sum equals 0, and then not, people got it pretty quick. Okay, so we need a way of calculating the distances between the vines. So first equals 0, second 0. Now let's see. Trying to think. So with the loop structure we have here, we're pulling out each vine in the vine list. And here we have the vine list being built of all the vines. So for this example, this test, it would be 530. So now I need, so actually, I'm going to do it a little bit different. We're going to do index. We're going to switch the loop structure to a while loop. I feel a little more comfortable working with it that way. While index is less than len vine list. Index increments, so we don't get an infinite loop. All right, now sum plus equals the distance squared. Here, we're printing the sum. Okay, so here we need to do vine list at index plus vine list at index plus 1 divided by 2. No. Minus, take this back out, and what we should actually do, dist equals I love that picture, or Wallace. Anyways, sorry. If distance less than 0, distance times equals -1. All right, sum plus equals distance squared, and there. Did that do it? Oh no, we've got, oh yeah, we didn't declare this. Distance equals 0. Or initialize. And we don't need first, second. That's what I was trying to think, how to target those two, get the difference. Okay, 17. What's wrong with -1? There. It was an indice error. Did we get all of them? Nice. All right. I believe that's. Oh, nice. What's up, Nilam? Oh, you did it faster than me. I took like closer to like 5 minutes. But yep. Share your code. Oh, hey, what's up, time traveler? Sorry, I didn't see your comment. Welcome. All right. Let's do another clash. Hey, hey, we're in the same one again. In this one too. Oh, at least I've been told this is what you need to do on these streams. Let's go ahead and throw that in there. There. Send the link before the clash starts. I'm not sure. So, just in case, there it is. Let's see. It's hard to tell if I've done two or three. Or actually, never mind. I've got 3 links, so this is my third clash. That's an easy way to tell. Alright. I don't even know how many that means. Oh gosh. Oh gosh. Like it's like, just kidding, we're starting this clash now. Alright. Another fastest mode. They're all fastest today. Alright, so given a list of n numbers, either 1 or 0, you need to output the result of XORing over the list. To do so, you have to XOR all the elements 2 by 2. Start at the beginning. Okay. I liked it up until the 2 by 2. So, I mean, so the XOR, the concept of that, what's going on here? Let's see. Yeah, that 2 by 2 is tripping me out. Because, I mean, basically, if you were to XOR, like if you took this one, it would be 0, 1. It would be the opposite. So, it's an exclusive OR. So, for here, it would be 1, 0, or no, 0, 1, 0, 1, 1. To do so, you have to XOR all the elements 2 by 2. Oh, okay. So, alright, let's do it kind of like we did the last one. Index equals 0. Let's do a while loop. While index is less than, we want to do bit string equals an empty string. What we're going to do is bit string plus equals string cast of x length of bit string. Oh man. Excuse me. So, the reason I'm doing that, and then we're also going to need to cut that -1, because just like we did last time, we're going to do 2 by 2s. So the first one and the second one, we've got like 3 conditions. So let's see. If bit string at index equals 1, and this is going to get kind of ugly, but we're doing it for speed. Index plus 1. Wait, I'm trying to think of what an XOR is. When you're doing it 2 by 2. Sorry, I'm having a little bit of a... Oh, and then we also do return string equals... So initialize a return string, and we're going to be building that return string plus equals... I don't know if that's true, because... So if we got 2 bits... So I know in an XOR... That's one of the ones that you rarely use. That's my least used operation. And or are easy. If you got the two, the first one's one, the second one's zero, or the first one's zero and the second one's one, and or will always give you one. One and one with an and. So I believe that's right. If it's one and one, zero. I mean, there's only three different situations, or four. There's four different situations it could be. Oops. Oops. No. Okay. They can either both be ones, both be zeros, or you can have one of each. And let's see. So that's 1, 1. Let's do 0, 0, which is also 0. I think the only time the output is a 1 is if only one of the inputs is 1. Now, let's see. I think that's good. You go ahead and return. I think that's good. Oh, nice job. No. Oh, right. Yeah, the up caret. That's right. Oh, also index plus equals 1. Okay. Infinite loop. Hmm. Yeah, if we did the XOR with the up caret, that would actually probably be a cleaner way to do it. So like for this, it would be turn string plus equals um, string version of bit string at index XOR bit string at index plus 1. Okay. Now, do int let's just comment all of this out. Expected 0. Why is it expecting? Let's see, output. Hmm. So it's just expecting a 0 or a 1. So, okay. Huh. Now this I don't get. Because what we did is we XOR'd So should it just be the XOR of the last two? Nah, that wouldn't be right because this one, it would be 1. So it wouldn't be the last two. This one it's 0 and 1, which would equal. So it's almost like we have to do this until we got to keep doing it. Ah, jeez. Hold on. I'm like pretzeling myself. All right, so if I'm understanding this right, we would need to continue to do the process until we shrink it down to a single digit, either a 1 or a 0. So like that's our first iteration of XORing. So we would need to do it again. So we would almost need to wrap all of this in a while length of return string is greater than 1. Do that. And need to make return string 1, 2, 3. Actually, let's just do that. Wait a minute. We could do it while bit string is that big. Let's see, how much time do we have left? We got like almost 5 minutes. Alright, so what I'm thinking is, now we're shrinking it down until it's like base case, basically. So for this one it's 0 because it's 1 and 1. Oh geez, and we got an infinite loop. Let's see. Return string is always going to be greater than 1 because we didn't actually change it. So I think we should do it while bit string, and then we just need to change bit string to the finalized. So after we, so at the end here, bit string equals return string equals there. Alright, now we need to do this bit string. Let's see where that puts us. Nothing. 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 Okay, so okay. So return string. Let's see. So this is the XOR of those two. Okay, and by doing this, let's see, and we're constantly changing this, but that should be okay because we're using a new bit string every time and we're doing an XOR operation on it. And then we're changing the new bit string for the next iteration to that return string. Yeah, we want to do that after this entire inner while loop executes. So what am I missing? So somehow we're not updating it, or we're updating it too much, or something like that. Because bit string is nothing. Let's do a printout here. Let's see what we're at. Bit string. Let's see what that gives us. So as we're going through it, there's 11, there's that. Okay. Now let's also do, I want to see what it is here. So at the end of this for loop, let's print bit string. So I think we're on the right track. So we should have, come on. Alright, so that's the initial, and then that's after the first one. So if the first one we've got, but the XOR of a odd length string yeah, no, that's right. Because yeah, we're XORing 1 and 0, and then we're XORing 0 and 1, which gives us 1, 1. Let's try one of these other ones. So we start here. So that's a 1, that's a 1, that's a 1, then that's a 0. So that looks correct. That looks good. Um, the only problem is, okay, so now we start with that here. So we got that, and we've got the conversion right. So now we print this bit string. So then we're done with this loop, or this iteration of that loop. So then this bit string gets plopped back here. So the length is still greater than 1. So then we do it again. We build a new return string. So this should change to 0 plus 0 plus 1. And that should change to 0. So actually, the answer in the end, oh yeah, 12 seconds. We didn't quite get this one. So the problem I'm having is we've only got these two printouts, but we need to keep going. So somehow we're not going to go through, but that's good. Timed out. But whatever. Anyways, what I was saying, let's go ahead and let's take a look at this again because we've got. We could do one more clash and keep this around in like an hour, but basically, well, let's share the code and let's actually look at someone who did it in Python. Okay, that's way complex. Nicely done, but basically, so yeah, they've got X. They're making a string, so they've got the string of the bit string, and then now they're assigning it to. And see, that's what I try to shy away from. That is because like even though that works, obviously, they passed all the tests, but it's just a lot going on all at once. So the way that this line is evaluated, I can see a lot of bugs for myself. But I mean, it makes sense. So we're doing. Actually, they're going reverse. It looks like. Why did they hardcode -3? And they reversed it. Because I colon -1, I think that's the step, so you're going backwards. I mean, and then here they have x minus 2, x minus 1. So the indexing, they're taking the last character and then the second to last character, XORing them. Very fancy. Nicely done. But we didn't quite make it on that one. Let's go ahead and do one more clash. Then I think I am going to go for like a walk or something. So, alright, let's go ahead and plop that down to. And thanks for that tip, Chief Chippy, that XOR, because that made it a lot easier than whatever that jumbled jargon I was doing. Um, and I've done that before. That's like hard coding the different conditions, the different situations. So taking the concept of an XOR and just putting in the different combinations of this one and that one, ones and zeros, which we figured there was 4, but that just made it a lot smoother. So anyway, kudos, thanks for that. And how many clashes we got? So that's yeah, 4 clashes. That's not terrible. If we do this one quick, maybe we can do a 5th one, but at least we're still hitting the. I mean, at least we're getting 4 in an hour, the bare minimum. So it's gonna take a while to get 400 of these things. I might do some off stream. In fact, I'm pretty sure I'll do some off stream where there's a little less. Not that there's a lot of pressure. I fumble through these a lot. Worst case, they take 15 minutes. That's cool. All right. Cool for you. You must output the surface area of the given dimensions of a rectangular prism, cuboid, or box. Okay, so we're just declaring the surface area, which would be. Isn't that. Let's see if that's correct. Isn't that just length times width times height? Length, width. Let's think about a rectangular box. So we've got a box, length, width, height. So there's 6 sides. If you're thinking of like a dice, there we go. So It'd be length times length plus width times width plus SA equals length times length plus width times width plus height times height. I believe. No, it is not. Okay, so let's think about this. So if we have a box, it's got 6 sides. That's what I was saying. There's 2 of these, 2 of these, and 2 of these. Because you think about with just a dice, you've got the front, the back, then you've got the top and the bottom, and the left and the right. So you got 6 sides, so it would almost be like 2 times, whoops, say plus equals 2 times. Oh, well, there's one of our issues. SA plus equals 2 times. What is that? It's supposed to be times. How close are we with that one? Alright, we're getting. Ooh, we're getting very close. So why are these off though? We're only 2 off. That one we're twice over. That one we're 6 off. Hmm. Trying to think of why that would be. I think it's only 2 off there. Let's go ahead and so let's take a look at the values that we're failing on. So for this first one, we're off by 6. So that's a length 3, width 4, height 5. So we have 2 sides of 3 by 5, so it's 15. For the surface area of that side and the surface area of right and left. So let's go ahead and. So we got 15. 3 times 5 on the right, 3 times 5 on the left. And if we're doing 3, 4, 5. So that means. Nice if we could just draw a box. So we've got length 3, 4, 5. So we've got 4 as the width, 5 as the height, and then. So that's kind of, if you could draw like a line here for 5 units, and then 4 units this way, and then 3 units deep. So that's not the best picture, but trying to kind of visualize it. So we have sorry, let's see. So yeah, we have 2 of these, the front and the back, which are 20. So we've got 40 right there. And then 2 of the 15s, so that's actually 30. So for the left and the right side, we've got surface areas of 15 and 15, so that's 30. For the front and the back, we have. Then there's another 30 for the top and the bottom, because that's 3 by. Wait. No, it's 12 and 12? That's 24. So then 40, 70, 94. That's how we get the 94. But okay, so what am I doing wrong? We've got that's why, because it's not length times length. These are not all squares. It's so to do. We could even do comment left and right, top and bottom. Oops. And front and back. So, and those aren't not even the. So wait, we have 3, 4, and 5. We have length times width times height. So we need 2 times length times height, and that would be the left and the right. And then for this one, we have top and bottom, which is length times width. Then this one is front and back is width times height. Let's try that. Oh geez, we need to whoops. I got it. Okay, we just needed to visualize the dice. That's about halfway through. Shortest mode. We can go ahead and take all the visualization out. Take out all this. And I could actually make this, I could change that to LWH. L W H L L H W W H. Take these out. Take these out. I could make all of these. Let's make sure that still works. Don't know why we need to import math. Yeah, we don't need math. I don't even know, do we need system? No, we do not need system. For some reason I was thinking input might be tied to that library. Okay, so now we've got that. I actually say this is pretty close to as good as I want. The only thing, we could take out the spaces and make it really compact. And we could also put all of this. Actually, I got an idea. I'm going to go ahead and put that there to preserve it. Then put this. Oh geez, we could also take care of all of these spaces. There, I played along with the shortest mode for once. Let's make sure this still works. I mean, our biggest offenders are just the words input. Oh geez. Guess we need to keep it like that. Or but STR, then 2 parentheses, so that's 5 characters. It actually doesn't work. So, yeah, let's leave it at that. Oh, did I break it? Oh, it still works. I'll take out the comments. Okay, that's pretty short. Also, how short did we get it? 82 characters. It's still not the shortest, too. I mean, we barely beat out. Let's go ahead and share that code. Two people gave up. Bash. Wow, that's See, I can't imagine doing these challenges in Bash. All right, let's do one more. Or where are we at? Just over an hour. Yeah, let's do one more. Okay. Let's go ahead and throw that in the chat. Oops. Oh, I only copied part of it. Apologies. I only got the, looks like the hash value at the end. All right, fastest mode. The Armstrong number is called a number. Okay. If we multiply each number by the power of the number of numbers, it becomes equal to that number. For example, consider the number 153. 153 is a three-digit number, so we multiply each of its numbers by the power of 3 and add it together. Oh, so you just cube each digit and add it together, and if the sum equals the initial number, then it's a strong number. And so then we print true or false. Uh-oh, let's see, wait, what is this? Output all of Armstrong numbers less than n, line by line. Ooh. Wait, what? 5 cubed does not equal 5. 4 cubed does not equal. Alright, I think I'm not understanding that correctly. So, like for this one, for everything less than 5, all of these are strong numbers, are Armstrong numbers. Let's see, 4. Uh, by this logic, so for 1 times 1 times 1 equals that. Okay, so that's fair. All right, then say for 3, right here, we've got 3 times 3 times 3, so that's 27. That is not 3. So this is 27 plus 1. What is that? Oh, that's the result of that last clash. Okay. So, I'm trying to think. Mm, I mean, first off, I don't think any of these numbers are Armstrong numbers because, except for 1, but 2 is 2 times 2 times 2 does not equal 2. It's 8. So I don't agree with this output unless I'm missing something. Because basically this output is just saying, hey, let's print everything less than 5. Alright, and so like while, let's go ahead and throw an index in there. While index is less than n, if index, this is where I would put in a helper method. Power is length of the digit. Let's see. Hmm. So this, I guess I should see. Well, first off, let's just go ahead and comment all this out. let's get it's a few test cases. Expected 1, and let's print. Ah, jeez, what's going on here? Print n. Oh, index equals 0. Let's just have that. I don't know, something, a placeholder. Alright, so we've got 5 and 1.